Hello, this is Mrs. Sargent, and this is lesson 1.5, metric conversions. So I have a little joke for you. No cussing, no use of the four-letter words here in science. We don't use the inch, the foot, the yard, mile, pint, or acre. Those are all English conversions, and we don't use those in science. We also never swear with the big F for Fahrenheit. We use degrees Celsius instead. So please keep it clean and use the metric system. We are going to talk about the SI units, which stand for the International System of Measurement. The SI unit for length is a meter. The symbol for that is a lowercase m. We don't really have any other units that we use for length that are not based off of the meter. We have millimeter, kilometer, centimeter, but all of those are based off the meter. So if we wanted to measure the dimensions of an iPhone, we would do that in centimeters. If we wanted to measure the length of the stick pin, we would do that in millimeters. If we wanted to measure the height of a basketball hoop, we would do that in meters. And if we wanted to measure distances in Nebraska, like say we're going from Omaha, traveling to Colorado, and we make a pit stop in Scotts Bluff, we would do that in kilometers. The SI unit for mass is a kilogram. And the symbol for that is a lowercase k, lowercase g. We don't really have any other units that are not based off of the kilogram. If we wanted to take the mass of the iPhone, we would probably do that in grams. Where if we wanted to take the mass of the stick pin, we would probably do that in milligrams. And then if we wanted to take the mass of a textbook, we would probably do that in kilograms. The SI unit for temperature is Kelvin. The symbol for Kelvin is a capital K. And the other units that we use are Celsius, the symbol for that is degrees Celsius. Notice Kelvin does not have the degree sign. There is no degree sign with Kelvin. So if we wanted to make some tea or some coffee, the first thing we need to do is we need to boil the water, which happens at 100 degrees Celsius. And to find the temperature in Kelvin, we're going to take the degrees Celsius, add 273 to it, and we get the temperature in Kelvin. So T is either 100 degrees Celsius or 373 Kelvin. For ice, water freezes at 0 degrees Celsius or 273 Kelvin. So 0 degrees Celsius is 273 Kelvin. 0 Kelvin is considered absolute zero, and we will look more at that later in the year. We're going to watch a video about some scientists trying to achieve absolute zero. The SI unit for time is seconds. The symbol for this is a lowercase s, or you can write SEC. Those are used interchangeably. But next to the other unit box, if we wanted to time someone running like the 100-meter dash, we would do that in seconds. If we wanted to time the burst between fireworks on the 4th of July, we would probably do that in milliseconds. Volume and density, these are derived units, which means that they are based off of multiple other units. So for volume, the SI unit is cubic centimeters. The symbol for this is cm3 in the exponent, cm cubed. And the other unit that we use typically for liquid would be based off of a liter. So if we wanted to determine the volume of a soda in a can or a bottle, we would do that in milliliters, and actually that's normally in parentheses on the bottle or on the can. If we wanted to determine the gas can volume, we would do that in liters. If we wanted to determine the volume of this aluminum cube, we would do that in centimeters cubed. You should know that 1 cubic centimeter is equal to 1 milliliter, which is also equal to 1 cc. So if you've ever watched medical shows and they talk about push 10 cc's of epinephrine, that's referring to 1 milliliter, or 1 cubic centimeter. Typically, cubic centimeters are used for solids, and liquids we use milliliters or liters, but they can be used interchangeably. Density is in grams per cubic centimeter. So G/cm3. We can also use grams per milliliter. So if we wanted to measure the density of the aluminum cube, we would typically do that in grams per cubic centimeter because it's a solid. Or if we wanted to measure the density of the vegetable oil, we would do that in grams per milliliter. So we've looked at all of the different SI units. Now we need to know how to convert from one unit of measurement to another. Well, we talked about the different prefixes that are based off of those units. So we're going to fill in this diagram. It's a number line that's going to help us with our conversions. The bigger amounts are going to be on the left, and the smaller amounts are going to be on the right. So our base units are here in the middle, and those are grams, which the symbol for grams is a lowercase g. Meters, the symbol for that is a lowercase m. And then liters, which the symbol for that is a capital L. So notice that the base units are here at 1. 10 to the third is kilo. And the symbol for that is a lowercase k. And so we can have a kilogram, because this is a prefix, kilogram, kilometer, or kiloliter. Those are used, this prefix can be used with any of those. 10 to the sixth is mega. Which is a capital M. And then 10 to the ninth is giga, like a gigabyte. And the symbol for that is a capital G. On our smaller units, if we go over 3 places, we have 10 to the negative third, and that is milli. And the symbol for this is a lowercase m. So notice meters is a lowercase m and milli is a lowercase m. So if you just have one lowercase m, it is referring to meters. If you have 2 lowercase m's, it's going to be millimeters. If you have mg, this is milligrams. If you have ml, it is milliliters. And then 10 to the negative sixth is micro. The symbol for this is some people say it's a funky looking M, other people say it's a funky looking U. It's a Greek letter, and this is what it looks like when the computer types it. So like on your quizzes and tests, this is what it will look like down here. And then 10 to the negative ninth is nano, and this is a lowercase n. There's 2 others I would like you to know, and that is 10 to the negative first, which is deci, D-E-C-I, and this is a lowercase d. And then 10 to the negative second, which is centi, and this is a lowercase c. So we can use this number line to convert from one unit to another. So we have these numbers at the top of the next page, 2,400 grams. So we are going to start here at our base unit because that is what we are given. And we want to convert to kilograms. So we're going from base units to 10 to the third, which means that we're going to move our decimal 1, 2, 3 places to the left. So 1, 2, 3. So 2,400 grams is equal to 2.4 kilograms. .05 kilograms. So let me go through and erase this so we can look at this again. 0.05 kilograms is where we're starting, and we want to go to milligrams. So now notice we're moving the opposite direction on the number line, so we're going to move our decimal in the opposite direction, so to the right. So we're moving it 1, 2, 3, 4, 5, 6 places to the right. So 0.05, 1, 2, 3, 4, 5, 6. So 0.05 kilograms is equal to 50,000 milligrams. Go ahead and pause the video and try the next two on your own. Welcome back. So 9.3 kilometers, we're starting at kilometers. We want to go to meters, so we're going to move our decimal 1, 2, 3 places to the right. So that is going to be 9,300 meters. And then 13 million micrometers. We're starting here at micro, and we want to go to kilometers. So we're moving our decimal 1, 2, 3, 4, 5, 6, 7, 8, 9 places to the left. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So 0.013 kilometers is equal to 13 million micrometers. So that is it for metric conversions. I should note that there are some other prefixes that we didn't discuss, but these are the ones that you will be using primarily, so these are the ones I would like you to work with. There are practice problems on the next page, page 13, over metric conversions, so go ahead and take a look at those, and stop by and let me know if you have any questions. Thanks for stopping by YouTube. Have a great day.